Okay, guys, we're going to talk about graphing and inequality now. So I don't have an equal sign there anymore. So, lucky for you, ladies and gentlemen, the first part, the actual graphing of the parabola, nothing changes. I'm still going to do everything that I normally would do. If you want, do you want to answer A through H on one like this? Just remember how. Great idea. Okay. So on your quiz tomorrow, I'm going to be asking you for the A through H stuff, which for everybody in YouTube, here's what I asked them to find. So they're going to answer these things for number 9 right now. Okay? So for this, I'm going to have to find my vertex. I don't get it for free. How do you find the vertex in standard form? Great idea. Yes. So Maddie says, how about we divide by 2?
I think that's a great idea.
I do too. So then, and we can ignore that it's an inequality for a few minutes. That's only going to come into play when we go ahead and graph, okay? So I'm just going to deal with, if I divided it both sides by 2, replacing that with a 0, x squared minus 6x plus 10. All right, let's go ahead and find our vertex. How do you do it again? Anybody know? Negative b over 2a. That's it. So 6 over 2, I get 3. And so my vertex is at 3 comma something. How do I find the something? I have to plug 3 back in. So it'll be 9 minus 18 plus 10. 1?
Okay.
Everybody agree? Okay. So B I know is going to be x equals 3. C is the parabola up or down? Up. D. By the way, you're always going to be referring back to the original, okay? Because what if it had been negative 2 and you divided by a negative 2 away? So be careful. Always look back at your original for everything else that you're looking at, okay? D, max or min?
Min.
It'd be a min for the vertex, right? So the lowest point you ever have. E is the range, which is always x equals all reals. F would be the range. Did I say range for this one? I meant domain. Okay, so the range would be y is greater than or equal to, and it's always the y coordinate of the vertex, which is 1. G is the y-intercept, so you're going to have to go all the way back up to the original, not anything that you've done to it, because this is, right, if I graph these two parabolas, they are different, right? Look at A. This is a normal shape one. This is a narrow one. So they're going to, the only thing that's going to stay the same between them, oh, shoot. Oh, I'm just thinking something. I don't think we can divide by 2 to find our vertex. I think you can only do that when you're solving. Oh, shoot. Hold on. Let's see if it comes out the same. I don't think it will. Negative b over 2a. Oh, it does. It's 3. But then let's plug it back in. That'd be 18 minus 36 plus 20. Negative 18. Oh, it's not the same. Oh my gosh. Oh my gosh. YouTube. Oh my gosh.
YouTube.
Forget that I said this.
That's a way
So,
to do it.
we can divide both sides by 2 when we are solving for x. So when we are finding our x-intercepts and we replace y with 0, because you can divide both sides by 2 and it's gone. So it's going to cross the x-axis at the same location, no matter what a is, whether you divide it away or not. But that would mean that the vertex has to move, right? Because if it's going to be, I wish I had like,
You have to restart because you just someone's going to wash half of it and then
so these two things are going to cross, I don't know where our, let's just say our two x-intercepts are right here, right? And this one's what, up or down? Up. Okay, so if it had like a normal a is equal to 1 shape, Maybe it'll look something like this. Whereas ours is, our A value is 2, so it's going to be a more narrow graph than this. So it might look something like this. So see how the vertex is going to be in a different location. It's going to hit the x-axis in the same 2 spots, but it's also going to change our y-intercept. So we can only divide away by 2 when we're solving. My mistake, yeah. No, your vertex is going to change. So it's not 1 anymore. It's still at 3, but now look at our value. When we actually do the math, that's negative 18 plus 20 is now at 2. Right? Yep. Oh, you're right. Oh my gosh. Change F to a 2. Yes.
So if you wanted to use that like sheet with the down 1, down 3, down 5, would you look at, and we were solving and you divided it by 2, would you look at the first equation or the second?
When you're actually graphing it? First, the original. Always go back to the original. The only thing that you can do is to find those 2 x-intercepts by dividing it away. Yep. Sorry, I didn't mean to mess you guys up. Okay, so G are y-intercepts. So let's look at the original. Finding that y-intercept, you plug in 0 for x. What would you get out for y? 20. So G is just going to be 0, 20. And then H, here's where we can divide both sides by 2 if we want, because we're replacing y with 0. So it was 2x squared minus 12x plus 20, right? So here, let's go ahead and divide both sides by 2. Can we factor this? Are there factors of 10 that add up to be negative 6? Darn it, I don't think so. So I would probably complete the square, since B is even and A is 1.
Yeah.
So let's move C to the other side. So we'll have a negative 10. What's my magic number?
9.
9. Add 9 to both sides. I get x minus 3 squared. Uh-oh. What's going to happen? There's none because I can't take a square root of a negative. So I don't ever cross the x-axis for this one. All right, so let's go ahead and graph it. 3, 2 is my vertex, and it's up like a cup. Yep, so that makes sense.
Couldn't you graph it first and
Then answer these things?
Yeah.
Sure, if you want. Now, I'm actually glad that we don't have any other points to put on here, because now it does matter that it's an inequality. Do you remember when you had one of these, the greater than or the less than symbol? Do you remember what the deal is with when you're drawing the line, when you did these in Alexandra? Yes, these have to be dotted lines, because it doesn't include the actual line. It's everything up to that line.
I thought it was the greater than or equal to that.
Nope.
These ones that do have the line underneath, this you're going to draw with a solid line. So in this particular case, when I go to graph my parabola, I'm still going to graph it with a nice smooth line. If I did not have that or equal to bar underneath, I would still draw my parabola, but I would need to draw it with a dotted line. And then I'm going to have to shade it as well. So let's figure out what our parabola is going to look like, and then we'll talk about the shading part. Okay? So this always holds true. Make sure that you know that. So if there's no bar underneath, it's dotted. If there is a bar, it's solid. My way of remembering this, and you can use it if you want, or if you have a better way, that's fine. This uses more ink to put the bar underneath, so I have to use more ink to draw my line. It's worked for me for 52 years, so maybe it'll help you. All right, so anyway, there's our vertex. I might as well go ahead and use the pattern, right, because I know it. So instead of going up 1, up 3, up 5, I'm going to go up 2. Maybe draw my axis of symmetry. And then I might go up 6. 1, 2, 3, 4, 5, 6 over 1, mirror it over here. Okay, so I'm ready to go ahead and connect those dots. We already established that my parabola needs to be drawn with a solid line, solid curve. So I'll connect this with a nice solid curve like normal. But then, if you have an inequality, you have to shade. So I want all the y values that are greater than this expression. So there's a very easy way to do this. You know it?
Yes. Wait. Actually, no.
So the parabola has basically divided your graph into two regions. You have the region that's inside the parabola, and then you have the region that's everything outside of the parabola. Those are your two regions. You used to do it with just a straight line, and you would either shade above or below the line. Well, now your line is a curve instead. Here's the easiest way to figure out which way to shade. Put your pencil on the vertex, and then if it says y is greater than, I just need to shade whatever region is above the vertex. So in this case, that'd be everything inside the parabola. And again, because we drew the parabola with a smooth curve, a solid line, every point on the parabola is also a solution. So all of these points are solutions as well as everything inside the parabola. And that's it. So that's the only extra thing that the inequality does. It just, you have to stop and think, okay, should it be a dotted line or solid, and where do I shade? But literally, if you just follow my steps, it's so easy. Put your pencil on the vertex, and then just look. If y is greater than, you shade above your vertex. If y is less than, you shade below. So, let's see if we could do the same thing with 10. How would you even, where would you even begin? Oh, you know what's a neat thing that we haven't talked about doing, but it can be very helpful. If you can factor, like if we go back to number 9, if we had well, that one doesn't, that's a bad example.
10 and 2.
But A isn't 1. Look at 12 real quick. If you can factor this, you can convert standard form into intercept form. Because remember, intercept form is just the thing factored. You might be able to on this one. I know we can on 10.
Can you take on X?
Yes, can I? Yes.
It didn't look right.
X times X plus 4. Now I have this thing in intercept form. So I already know where this thing is crossing the x-axis. Where?
4.
What'd you say? Isn't it going to be -4, right? -4 and?
0.
Yes. You just set each factor equal to 0, so one of them is just 0. This thing is crossing the x-axis at -4 and at 0. So where's my vertex?
Good question.
-2.
-2 comma something, right? So let's just plug -2 back in. That should be easy. So -2 squared is 4, plus 4 times -2 is actually -8. So isn't that -4?
Yeah.
What's the value of A? It's 1. So I can just go up 1, up 3 is already there, and I'm pretty much done. Do I connect this with a dotted or a solid? Dotted this time. And make sure it's clear that yours is dotted. And now, as far as the shading goes, put your pencil on the vertex. Look at what the original says. Y is less than. So where would I shade? I'd shade down. And down really is everything outside of the parabola. So in this case, when you're shading, just to be very, very clear, if you have forgotten, when you are shading, you're saying these are all the possible answers. It's not just one answer, right? There's millions of them. right? Like, let's say that your parents and guardians say you need to be home before 10 p.m. Well, there's tons of times that you could come home before 10 p.m. 9:59, 9:58, 9:57, right? There's not just one answer. There's a ton of answers. So what you are doing when you shade a portion of a graph, what?
Technically, that's before 10 p.m. So I mean,
What?
Not.
3 in the morning. Yeah.
Of the day before.
Yeah.
Yeah. See.
So anyway, when you're shading, you're saying all of these things are a solution. So if you took any point that you shaded over and you plugged it in, you should come up with an inequality that's true. If you plugged in a point that you didn't shade over, it should be an inequality that's false. What if I plugged in a point that was on this parabola? Would it work or not work?
No.
It should not work because that's why you have a dotted line. Because it's saying the answers on this line don't work, but everything up to it works. That's the difference. Okay? So even if you had one like number 8, and it was, I know this one's an equal sign, but if it was an inequality, you do everything the same way that we've been doing. Right? So just graph it like you normally would graph it. And then it's just the last two things that you have to think about. Dotted or solid, and which way am I shading? So, is graphing inequalities too bad? No, it's not bad, right? You just got to remember those two things. Which way and shade. Okay? So, if you glance at the rest of these, could you do can you graph all of these? You have standard form, you have vertex, and you have intercept. And some inequalities. Are there any that you're like, I'm still not really sure how to do this, that, or the other? Sure. Actually, I'm glad that you asked about 7, because this is one of the most common types to mess up. So, just to practice inequalities, could we also change this to be y is greater than or equal to? Just so we have a little bit more practice with the inequalities. So, change yours to be greater than or equal to. All right, so where to begin? I would probably start by finding the vertex. Negative b over 2a. Let's go for it. Negative b over 2a. What do you get? 4 over negative 2. I get negative 2 comma something. Oh, I'm actually so glad that you asked this one. Can everybody please find the y coordinate of the vertex? Do not say it out loud once you get it.
This saved you. There was like a rule if there was a negative
Mm-hmm.
x. I forgot it. It was like,
Just do what you think you're supposed to do, and we'll see if you did the right thing. Because if you're doing what you're supposed to be doing, then it's ingrained in your brain already. If you're doing the wrong thing, we're going to ungrain it. I don't know how, but we'll try. Okay, did everybody get the y coordinate? All right. There's 2 things that people probably got as an answer for the y coordinate. Let me figure out real quick what they might be. I probably should have done that already, but I didn't. Okay, so some of you, I bet, got some of you probably got negative 1, and then some of you probably got 7. Did anybody get a number other than either negative 1 or 7? You got negative 5? What'd you get?
First time I did it, like, before I asked you, I think I got negative 17, but now I got I don't know.
Yeah, I don't know either. Maybe you had the x. Did you have negative 2 for the x coordinate before? Okay, so it obviously can't be both of these numbers. It can't be negative 1 and and 7, so it's got to be one or the other. Well, which is it? Negative 1 is correct. So Here's the thing with this. Let's talk about it again because it's so important. When you have, look right here. See this? See? This notation, recall, means take whatever x is and square it, and then take its opposite. So whatever you plug in for this chunk right here, it will always spit out a negative number. Always. Because you're going to square a number, which is always positive, and then take the opposite of it. So I guess I shouldn't say always, unless it's 0, because 0 doesn't have a sign. But anyway, so if I plug in -2, -2 squared is -2 times -2. That is positive 4, yes. But now that means take the opposite of it. So this is now -4 plus 8 minus 5. So I get 4 minus 5. That's how I get the -1. Okay. So, -2, -1, there it is. And now, since I know the pattern and I'm pretty good at it now, I'm just going to follow it. So if a is -1, where do I go from here? Down 1 over 1. And then to get the next point, I go down 3 over 1. Okay? Because we turned this into an inequality, I now have to ask myself, solid or dotted? Solid, because it does have the or equal to bar underneath. And then put your pencil on the vertex, and you look back at the original. It says y is greater than or equal to. So I shade, yeah, I would shade above this graph, which is everything on the outside. You will only ever have two regions. It's either inside the parabola or outside the parabola. All right, does this make sense? We're all okay? All right.